Hey, this is the demonstration on our Singer project regarding data transformation in the cloud. We're excited to introduce ourselves and explain this project in more detail.
Hi, my name is Jerame, and my background is in Amazon Web Services and mobile development with Swift and React Native.
Hi, I'm Chris. I aspire to work in application development, whether it be web or mobile. Most recently, I worked as a technical engineer on contract at Intel.
Yes, I'm Santiago. I'll be graduating this year. I'm getting a bachelor's in science in computer systems, but I'm looking to move more towards data analytics, data science, and data engineering. And finally, Kyle is our sponsor. He works at HP and previously a graduate from OSU, and he helped us guide us through the project and created the project. We had another group member named Josh who left our group, unfortunately, around 2/3 of the way through. We'll discuss that in more detail. So let's talk about the project. The project focuses on the extract, transform, load pipeline. This is extracting data from an outside API source, in our case, recreation.gov and National Park Service data, campsite data, transforming the data in our backend using Lambda Functions and S3 buckets, and loading that data into S3 buckets and RDS databases to keep it persistent. Ultimately, we send that data back to the user on the front end to view for themselves. After the first term, we created this outline with exactly what we want our project. Unlike other Singer projects, our project was very open-ended. And so this, although it was very confusing and there's a lot of arrows, kind of outlines what services we used and how we planned on going about using them. And this is the actual the services at the end that we ended up implementing. We did not implement this entire diagram. This is more of kind of a wish list or initial planning, but this is the bulk of the backend and it serves as the bulk of the process of data transformation.
Let's start with a quick overview of our web application. Here we can see bronze level data along with silver and gold level data. These data sets are publicly available, but are actually currently present in our S3 buckets. The download data button allows any user to download the data that they see directly in front of them. Here at the bottom, we have our try it out section. The tables are our S3 buckets that hold our data. Currently, you can see that they're empty. Let's start by uploading a couple of pieces of data and watching the pipeline work in action. Browse. Now we have to wait a couple of seconds as AWS processes our data, and then we can update our UI to reflect so. Nice. Now we can see that the two files we just uploaded made it into the raw data bucket, silver, and finally the gold level data bucket. The process we just saw is known as the extract, transform, and load pipeline. We start by extracting the data and uploading it to the Amazon S3 buckets. In our case, we are using open source campsite data from recreation.gov and nps.gov. In the transform step, we're actually manipulating the data. When the raw data is placed into the bronze level data bucket, the bronze to silver Lambda function is triggered. First, the data is downloaded. From here, we remove any empty entries, conflicting entries, standardize their attributes, and other things. The function then places the new silver level data into the silver level data bucket. Next, similar to the first function, the silver to gold Lambda function is triggered. In this function, we create a third data set based on relations and similarities that we found from the silver two sets. Finally, we load the gold data into the gold level data bucket. The data is also loaded into an Amazon Aurora database, but we don't do anything with that data, as will be explained in a bit. The final level data is available for download in the gold level data bucket. This is the end result of our pipeline, and this data set is downloadable and is the one that should be used for further analysis and any other visualizations.
Started the actual development section of our project. So we started building the front end to work with an SQL database that would be hosted on AWS. This was simplified into a front end using Lambda functions to handle microprocesses in AWS S3 buckets rather than the database backend, which accomplishes the same goals and expectations. This change occurred because we lost a team member who was primarily responsible for the databases. So let me show you the S3 buckets here. So here's our main bucket, which is 3 sorted tiers down below. You have our bronze, silver, and gold, each stored in their corresponding location. And you can see more file info if you click on the specific file. Next, we'll get into our Lambda functions. A big part of the project was finding 2 compatible data sets. After we researched how to correlate the data through techniques such as data blending, the Lambda functions automatically strip down the raw data and store the new silver data in its corresponding S3 bucket, as we showed in our previous slide. Silver data is automatically blended into a gold set by matching the loop attribute of our recreation.gov data to the camp name attribute in the NPS campground data. Triggering this process flow is simply tied to a file upload. Drop a new file into the bronze bucket, and the strips will automatically begin to process this data. I'll give you a quick demo here of our Lambda function. Here's some basic logging that you'll see. Let's get a little more into the code first. So you can see each function has a simple JavaScript that's being run. It's a little dense, so I won't go too into the code itself. We have 2 of these, one for the bronze data and one for the silver. So the actual logging is one of the more useful parts. You'll see all our informational logs here in CloudWatch for this specific Lambda function. An example of what a data set might look as it's logged through this is here. This is our recreation.gov data, and so you'll see an entry for each campground loop. We started the front end by deploying a React front end on an AWS free tier EC2 instance. As the product developed, this instance was upgraded 4 times into what is now a T2 medium instance due to resource requirements on the front end application. Once our data was selected, we deployed bronze tables to display our mostly raw data. Naturally, we deployed silver and then gold next. See a sample bronze and silver data from both resources on our web page. I'll pull that up right now. And then down below there is a blended gold table displaying the matches. So here is each table with scrolling attributes. There are live download buttons here that connect straight to the S3 bucket, so you can download data live. And I believe this is already demoed a little bit, so I won't go too into the front end. One thing to note about the gold table is that there are some duplicates here. That's because the loop attribute in the recreation.gov actually has quite a few duplicate entries for different campsites within the same campground. So this caused some duplicate entries in our gold data. We are currently working on a script that will strip this down and make it a little cleaner to look at. The final thing I want to demo is our actual EC2 management console here. These are all of our instances that we played with, doing some different experimentation with memory limits. Since this runs on EC2, which is really just Linux in the background, and this is assuming there's a technical audience for this product, we're not going to go too much into the actual console. It's simply just a Linux shell running a Node.js application.
So this wraps up the explanation for our final project. Our goal for this project moving forward is to keep it open source and available for users to use datasets we pull from. We're all committed to continuing this project past school. This is a very large and committing project, and although we're proud of the progress we've made, there's still a lot more we want to do and a lot more features we want to implement. We want to thank Kyle, our sponsor, for creating this project and guiding us through the AWS ecosystem, which was new for all of us, and our professor for guiding us through the class and providing that service. We hope you found this presentation informative.